Okay, so you probably think the rules of measurement were settled a long, long time ago, right? I mean, we all get the exact same foundational physics lesson in school. The universe is mapped out by this neat, tidy set of 4-unit systems. But, well, science has a funny way of hiding vast, mind-bending complexity behind a very neat curtain. Today, in this explainer, we're pulling that curtain all the way back. We are going to reveal the hidden systems of units that truly map our physical universe. We're exploring a highly specialized language that doesn't just dictate high-level theoretical physics, but actually serves as the invisible operating system for the most advanced artificial intelligence models running today.
And that brings us right to the big question. Are there really only 4 systems of units in physics? That's the simplified framework they package up nicely for us in school. But as you're going to see, the toolbox that scientists, and modern supercomputers for that matter, actually use is much, much bigger than that. In fact, the deeper you go into understanding how the universe operates, the more those basic tools just completely break down. But before we jump into the hidden systems running the cutting edge of science, let's make absolutely sure our foundation is solid.
Look, we all know what a system of units fundamentally is, right? It's a standard set of measurements for length, mass, and time. But if you want to understand why we rigorously need them, just look at what happens when they fail. Back in 1999, NASA lost the $125 million Mars Climate Orbiter. And get this, it didn't burn up because of some incredibly complex propulsion error or a miscalculated trajectory. No way. It burned up simply because one engineering team was using standard metric units and another was using imperial. Systems of units aren't just dry mathematical guidelines. They are literally the shared language of reality that prevents our rockets from crashing and our bridges from collapsing. Now, for decades, the standard curriculum has rested heavily on what we can call the Big Four pillars. These are the frameworks that governed classrooms, guided the entire Industrial Revolution, and basically provided the bedrock for engineering as we know it. They're a fantastic starting point for grasping how humanity first decided to chop reality up into quantifiable, bite-sized pieces. I mean, without them, we would never have been able to standardize manufacturing or build the modern world.
Think about the logical progression of those first 3 foundational systems, CGS, MKS, and FPS. They are quite literally named after their units for length, mass, and time. CGS relies on the centimeter, gram, and second, and it was super popular with early laboratory physicists doing small-scale benchtop experiments. Then, MKS scales things up to the meter and kilogram, which makes it perfect for larger, macro-scale engineering projects. And the FPS system, foot, pound, second, well, that reflects the historical, regional quirks of measurement that just sort of evolved organically over centuries. It's a really neat progression that shows exactly how different human applications dictated how we chose to measure the world around us.
And then, of course, there is the 4th and most dominant pillar, the SI system, or the international system. This is the heavyweight champion, the modern global standard. Expanding way beyond just those 3 measurements, SI relies on 7 base units, bringing in things like the ampere for electric current and the Kelvin for temperature. But here is an absolutely incredible insight. Back in 2019, the SI system actually completely redefined itself. We don't base the kilogram on a physical block of metal locked in a vault in France anymore. It's now tied directly to the fundamental constants of the universe, like the Planck constant. It really is the ultimate, universally shared vocabulary for modern science.
But here's where our shared reality takes a pretty hard pivot. Because the truth is, science is vastly bigger than these 4 pillars. The whole idea that there are only 4 systems is essentially a polite fiction. It's a simplification designed for introductory textbooks. It's the first step on a staircase, sure, but it is far from the whole staircase. Out in the wild, when you strip away those classroom simplifications, there are actually many, many more systems operating quietly in the background.
Behind the scenes, researchers, theorists, and computer scientists have developed an entire arsenal of what we can call hidden systems. Now, these aren't closely guarded secrets or anything, but rather highly specialized tools built for the absolute extremes of physics. Because when you get into the dense weeds of advanced science, standard tools like meters and kilograms actually become incredibly clumsy. They literally stop being helpful and start getting in the way of solving profound problems.
Take electromagnetism for a great example. If you try to use standard SI units to calculate electricity and magnetism together, the equations become insanely messy, just cluttered with awkward constants that completely muddy the math. So to fix this, physicists use the Gaussian system. It beautifully unifies electric and magnetic fields into the exact same mathematical dimensions. Then you've got EMU for isolated magnetic quantities and ESU for precise electrostatic forces.
These systems basically act like a mathematical scalpel. They strip away all the computational noise and make calculations in theoretical physics remarkably clean and elegant.
Now this is absolutely crucial, especially if you're following the AI space. Things get totally mind-bending when we push into quantum physics and computational modeling. This is where systems like natural units and Planck units come in. In natural units, universal constants like the speed of light are simply set to the number 1. And this happens to be a massive secret to modern artificial intelligence. Think about it. When AI models run these massive quantum chemistry simulations, if you feed them standard SI units with tiny exponents like 10 to the negative 34, their neural networks literally crash from floating point errors. The math is just too messy for the computer. But by using natural or atomic units, AI algorithms keep their mathematical weights perfectly normalized and completely stable. These hidden systems are the invisible language allowing artificial intelligence to simulate the fabric of reality without breaking down.
So, looking at this sprawling web of esoteric units, you really have to ask yourself, why do we do this to ourselves? Why on earth do we need so many different systems? Doesn't layering all these highly specialized frameworks on top of one another sound like a recipe for the exact kind of chaos that unit systems were invented to prevent in the first place?
Well, it basically boils down to this. Different extremes of reality require entirely different lenses. The math required to explain the gravitational pull of a black hole or map the spin of a subatomic particle is just staggering. Specialized systems act as necessary shortcuts to make that math elegant and actually computable for our AI models. But, and this is a big but, that level of extreme specialization is practically useless for everyday life. A system that is perfect for an AI calculating quantum gravity is absolutely terrible for, say, building a grocery store. Just imagine trying to buy a bunch of bananas by asking the cashier for 10 to the 38th Planck masses. Yeah, it just doesn't work.
Which brings us right back down to Earth, back to our shared everyday macro reality and the undisputed reign of the SI system. Because despite the incredible power of all these specialized hidden systems powering our AI networks and deep quantum research, humanity as a whole still needs a single unified champion. We need a universal translator to govern everyday science, structural engineering, and global commerce.
And SI became that undisputed standard for 4 massive reasons. First off, it's elegant in its simplicity. It scales incredibly easily with base 10 prefixes. Second, it is highly consistent across scales, from millimeters all the way to kilometers. Third, it's universally accepted. That means a materials scientist in Tokyo can seamlessly share open source data with an aerospace engineer in Toronto, and nobody misses a beat. And fourth, it is comprehensive enough to cover every physical quantity we interact with on a daily basis. That is exactly why it remains the ultimate anchor for the global scientific community. So, the next time someone tells you there are only 4 systems of units, well, now you know the real story. We study the basics for simplicity, and SI definitely rules our everyday physical world, but there is a vast, deeply specialized universe of units quietly powering the absolute cutting edge of science and AI right beneath the surface. And honestly, it makes you wonder. As artificial intelligence pushes us further and further into unprecedented quantum discoveries, will we eventually need an entirely new system of units, one invented entirely by AI that humans might not even fully comprehend? Stay curious and keep questioning the basics, guys, because the